Hello everyone, and welcome to the first part of our Python crash course. This section will cover everything that you need to know about Python in order to begin using some of the data analysis packages available, such as NumPy and Pandas, that I'll cover in the later sections. As mentioned earlier, for each section where we're using Python, you'll find a corresponding section folder that will contain all of the Jupyter Notebook files for that particular section. For instance, we can see here that for section 10, we have a Python crash course folder, and then within here, we have 3 different notebook files. The main notebook that we'll work through that contains all the relevant information, and then at the end here, we have our other 2 notebooks, which contain some practice activities, and then the solutions here at the bottom. If we click into the first notebook, you'll come to a page that looks something like this. So in the first lecture, we'll start by having a look at some of the basic data types available in Python. We'll then move on to some of the other topics like variables, the print function, indexing and slicing. And then finally, we'll have a look at some of the string methods available in Python. And then in the later sections, we'll cover some more advanced functions and topics. Instead, just going through this notebook here and reading out what I've already written, we'll create a new notebook, and then we'll go through the code that's been written out and explain what it does as we go along. So let's head back to our Jupyter Navigator and then create a new workbook. Let's get started by having a look at one of the most fundamental parts of Python, which are the different data types available. Python has got several different built-in data types, but the most common and straightforward of these are the numeric data types, strings, and booleans. Let's start by having a look at our numeric data types. There are 2 main types of numeric data in Python, and these are integers and floats. Integers are just whole numbers, so like 1 or 2 for instance, and then floating point numbers are just numbers that have a decimal point, like 1.5 or 6.2 for example. We can perform arithmetic on these numbers inside of our notebook like we saw in the last lecture. So we can just enter in 1 plus 1 in our first cell, and then if you run it, we'll get our output of 2. We can also perform other operations such as multiplication, division, subtraction, and exponent. This here is a list of all the different mathematical and arithmetic operators available in Python. Most of these will be quite familiar, but we'll have a look at modulus and floor division, which are some of the lesser known operators. Modulus can be used to return the remainder of a division. So for example, 9 mod 2 or 9 modulus 2 would result in 1 because 9 divided by 2 is equal to 4, and it leaves us with a remainder of 1. And then floor division basically discards the decimal point of a division. So 7 divided by 5 would be 1.4, but floor divided would result in a 1, as it just takes the integer part of our division and discards the decimal point. And let's have a look at an example back inside our Jupyter Notebook. So let's use modulo and go for 9 mod 4. And we can see here that we get our answer of 1, and that's because 9 divided by 4 is 2 remainder 1. And the remainder 1 there is the important part, as that's what mod returns. 8 mod 4 would be equal to 0, as there's no remainder. Next, we'll introduce the type function. The type function can be used to verify and return the data type of a value. So in a new cell here, we'll just type in the name of the function, and then, like in Excel, anytime that we want to use a function, we have to open a set of parentheses so that we can then pass in our arguments. So I'll pass in 10, and then if we run our function, below this, it'll return the type of that value, which in this case, as we'd expect, is an integer. If we instead change this to be 10.5, you'll see that we get a float instead, and that's because this is a floating point number. Our next main data type is the string, and there are 2 ways to create strings. So we can either use single quotes, or alternatively, we can use double quotes, and both result in a string data type. I'll notice here, when we enter our quotes and begin typing in a string, the colour of our text changes, and this indicates that we are entering a string. And we can use the type function just to quickly confirm this. And yep, we can see here that the data type here is an str, which is just short for string. Any numbers that are wrapped inside the quotes will also be classed as a string too, even if the string only contains numbers. So anything inside of quotes will be classed as a string. The final data type we'll look at is the Boolean, and Booleans are just simply either a true or false value. So to create our Boolean value, we can just simply type in either true or false. And we have to ensure here that the starting letter of each of these are capitalized. So a capital T for true, and then a capital F for false. And again, with the type function, we can confirm here that these are a bool or Boolean type. And this is great progress already. We've already been through and looked at our 3 main data types in Python. So let's now take this a little further and have a look at variables. Variables are an incredibly helpful feature as they allow us to store values for use at a later date. And to assign or create a variable, we'll need to use the assignment operator, which in Python is just the equals sign. To start with, we'll have to provide a name for our variable. So I'll call my variable x, and then we'll provide our assignment operator. So I'll enter in an equals, and then we'll have to provide the value that we want to store and assign to our x variable. So I'll just assign a value of 2. Below this, I'll create another variable called y, and I'll assign the value of 3 to this variable. If we output x to the console, we'll see that it outputs a value of 2, which is what we assigned to it earlier. Something to add here is that in Jupyter Notebook, we don't actually need to call the print function to output our data. We can just simply write in the name of our variable and run the cell. Whereas in other IDEs, you probably will need to call the print function, which we'll look at shortly. If we check the type of x, we'll see that it's just an integer. So we can actually add the values of x and y together. And as you can see here, it comes out as 5, which is what we'd expect from 2 and 3. And all the other operators that we looked at before, like multiplication or modulus, would also work too. It's also possible to assign strings to our variables as well. So I'll create a new string here called variable1 with an underscore between our names. And then I'll just assign the string of my first text variable. And of course, making sure that this is inside of quotes to make it a string. So as mentioned, in Jupyter Notebook, we can just write the name of our variable and run the cell. And then this will then output the contents of our variable below. In other IDEs though, this might not work, and we'll need to use the print function in order to display our variable or data. And the print function is basically a way of displaying a message to the screen. If we wrap our variable1 here inside of the print function and then run the cell, we'll get the same output, so my first text variable string again. But notice here that this time with the print function, we don't get the quotes around our output. And it is generally considered best practice to use the print function when creating code that you'll share with others. Let's now create another variable called variable2, and then we'll assign the string of in Python to it. We'll now perform some string concatenation to join these two strings together. Let's call our print function again, and then inside of our parentheses, we'll pass in the name of our first variable, but then we'll add in a plus sign and then provide the name of our second variable. So this is quite similar to what we did in Excel. And then if we run this, we get both our first variable and then our second variable joined together. And again, like in Excel, we'll need to add in a space between our two strings manually, as currently they're just glued together. So we can add in another string between our two variables, again using the plus sign, and inside of our string, we'll just add in a space. Now we can see that we have our full string with a space between the two of them. And as we can see here, when trying to concatenate multiple variables together, our code can quickly become messy due to the numerous plus signs needed. In order to get around this issue, the Python developers added in a feature called f-strings, which are otherwise known as string literals. And these were introduced in Python 3.6, and they provide a concise and easy way to embed expressions and variables directly into our strings. To better illustrate this, let's add in another variable, which I'll call my name, and then I'll assign my name to this variable. And let's now use f-strings to output our name along with the other two variables that we made before. And like normal, we'll start with our print function and then open our parentheses, but this time, before opening our quotes, we'll enter an f, so just the single character of f. And this then initiates our f-string. So now we'll open our quotes and begin typing the first part of our string. So I'll put in hello, my name is, and then at this point, we'll pass in our name variable. So unlike before, where we had to add in the plus signs, we can instead just open a set of curly brackets, and then in here, we'll pass in our variable name, which is just my name. Then we can close our curly brackets, and then if we run the cell, of course, closing our quotes and parentheses first, you get our output below with our string at the start, and then our name variable has been added on to the end of our string. Going back to our code, I'll add in this is, and then our final two variables in square brackets, making sure again here to add in a space between them both. Perfect. So this is a much quicker and easy way of adding in variables to our strings. Next up, we'll have a look at indexing. Indexing is a way of accessing individual elements or characters within a sequence or a variable by their position. Let's create a new variable, and I'll call it string, and then I'll just assign hello with an exclamation mark at the end. And then with our string created, you can use something called square bracket notation to index our variable. We'll write out the name of our variable and then open a set of square brackets. And within these square brackets, we can pass in the number of the position that we want to index or access. Something very important about indexing in Python is that our position number always starts from 0. So if we enter 0 into our square brackets and then run the cell, we can see that it returns the h from the start of our string. And let's have a look at a visual representation of this to better explain what's going on. So at the top here, we have our string, which was hello, and then with an exclamation mark at the end. Above each character in our string, we also have some numbers going from 0 to 5. And as mentioned, indexing in Python always starts at 0. So our first character, h, is at position 0. And then our next character, e, is at position 1, l at position 2, and so on for the rest of our string. We can also index our string backwards too, and this is called negative indexing. And with negative indexing, our start position is actually -1. So it's only regular indexing where we start at 0. And below this, we have two examples. If we indexed our string at position 1, it would return e, as this is the letter at index position 1 of our string. And remember, this is because h, our first character, is actually at index position 0. And then off to the right of this, we have an example of negative indexing, where we index at -3. And we can see here that this would return L, because working backwards, this is the character that is in index number -3. If we take our last two examples that we've looked at, index position 1 and -3, and try these in Python, you'll see that we get these same results as we did before. Next, we'll move on to something called slicing, which is similar to indexing. Unlike indexing, however, which only extracts a character from a single position, slicing enables us to extract a portion of or multiple different positions from within a sequence. Let's go back to our PowerPoint and have a look at how slicing works. So slicing uses the same square bracket notation as indexing, but instead of just providing a single number, we instead provide a range of numbers separated by a colon. For example, to slice from index position 1 to 3, we would have 1:3. When we apply this to our example from before, the slice of 1 to 3 will select the characters at index positions 1 and 2, which correspond to E and L. And you might be wondering why our second L hasn't been selected, seeing that index position 3 is part of our slice. The reason for this is that when slicing data, Python returns elements up to, but not including the stop value, which means that the element at the stop value is not included in the result. So this slice here is only returning elements up to index position 2. If we wanted to include the second L at index position 3, we would need to set the stop value for our slice to be 4. Now let's consider the slice of -4 to -1 for the same string of hello with an exclamation mark. Negative slicing works the same way as negative indexing. So -4 refers to the 4th position from the end of our string, which is L, and -1 refers to the position at the very end of our string, which is an exclamation mark. But since Python only returns values up to the stop value, and not the stop value itself, it will return up to the index position of -2, which is O. And therefore, our result of the slice of -4 to -1 for this string would be LLO. Before moving on, we'll quickly demonstrate the slicing examples inside of Python. We'll start with our variable name, and then inside of our square brackets, we'll enter in the start value, which we'll have as 1, a colon, and then our stop value at 3. And then we get the exact same result as what we had in our PowerPoint example. And then finally, for our negative slicing example, we had from -4 to -1, and here we get LLO, which is the same as in PowerPoint. The final thing we'll look at in this lecture are string methods. String methods are basically just functions that we can use to manipulate strings. We'll explore functions in greater depth in the coming lectures, but let's have a look at these now. On this PowerPoint here, we can see a list of all the different string methods available in Python. Of these, the methods highlighted in green are the most commonly used, and these are what we'll look at now. Let's start by taking a look at our case functions. These are the lower, upper, and title functions, and they work in a very similar manner to our case functions in Excel. For this example, we'll use variable1, which we created before, which just had the string of my first text variable. To call the string method, we start by referencing our string variable name, which is variable1. Then we can enter a dot, and this allows us to access the methods available on this string object. The first string method we'll have a look at is lower, which converts all the characters in the string to lowercase. And as this is basically just a function, we'll need to finish this off with a set of parentheses. And now if we run this cell, we can see we get our string in all lowercase compared to our original variable above. Next we have upper, and this just converts our string to be all uppercase. So again, we'll start with our variable name, and then followed by a dot, and then the upper method. And finally we have the title method for title case, and this does the same job as the proper function that we looked at in Excel. Okay, and those are our three main string methods for changing case in Python. Next we'll have a look at the count method, which we can use to count up the number of times a character occurs in a string. We'll type in the name of our variable, and then again we'll enter in a dot to access the available methods on this object. Well, this time we'll call the count method, and then inside of our parentheses we'll have to provide an argument, and that's the character that we want to count. So I'll pass in I, and this now will count the number of times that I appears in our string. And bear in mind, this method is case sensitive. Before we run this cell, let's have a look at our variable, and we can see that I appears 2 times. Once in our second word, which is first, and then again in our final word, which is variable. And if you run this, we'll get an output of 2, which is correct. And then the final thing that we'll cover in this lecture is the replace method. And this, as the name suggests, can be used to replace a character in a string. And let's say that we want to replace any occurrences of the letter I inside of our string with a capital X. So we'll call our method on our variable, and then for the first argument, we provide the character that we want to replace, which is I, and then our second argument is what we want to replace the first character with. So we're replacing I with a capital X, so I'll put a capital X in here. And note here that I've used a comma to separate our 2 arguments. And again, this method is case sensitive. And here we can see that both occurrences of I have been replaced with a capital X. And then just to show you quickly here, if we pass in another argument, simply just of 1, this limits the number of occurrences of the character that can be replaced. So now you can see that only the first I has been replaced with a capital X, and our second I remains as it was. Okay, and we'll leave it there for the first part of our Python crash course. In the next one, we'll go ahead and cover some of the different data structures as well as some of the operators available inside of Python. I'll see you all in the next lecture.